If you don't have a calculator, go right there on that office door and go get one. Okay. We kind of talked about this last period, but let's just go over it. When we are doing an average, like you're doing an average in math class, okay, you would take all of the things that you have, and then you would add them all up, and then you would divide by the number of objects that you had, right? That's how you would do average. Well, because we're dealing with atoms, they are too small for us to do that. We cannot do that. So we need to rely on something called percent abundances. How much of these atoms do we have? And let's go back to nice carbon 12 and carbon 14. Again, notice that I'm writing the 12 and the 14 afterwards. The reason why I'm doing that is because I want you to see it both ways. I want you to see carbon 12 and carbon 14. Okay? These are the same. They will never give you the atomic number. They will give you the mass number. Okay? So let's say we have a bunch of carbon 12s. Carbon 12, carbon 12, carbon 12, carbon 12, carbon 12, carbon 12, and let's do one more. Carbon 12. So how many is that? 7? That's 7 carbon 12s. Okay? And I have some carbon 14s. Carbon 14, carbon 14, carbon 14, carbon 14, and carbon 14. Okay? And the scientist takes a sample of carbon. This is what he's going to get. He's going to get a bunch of carbon 12 atoms and a bunch of carbon 14 atoms. So he took a sample from, I don't know, a dead woolly mammoth, and he saw that there were a bunch of carbon 12s, and he saw that there were a bunch of carbon 14s. Okay? What is the percent abundance of carbon 12s in this sample? So how do we calculate percents? How do you do percent? Go ahead.
You take the whole number of like all the carbons.
Okay.
And you divide it by the number of carbon 12.
Okay. So if we count how many carbons we have in here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 carbons. That's the total number of carbons. And we have, let's do a different color here. We have 1, 2, 3, 4, 5, 6, 7 of them are going to be carbon 12s. And how many carbon 14s do I have here? I had 5. 1, 2, 3, 4, 5 carbon 14s. That makes sense because they add up to 12. How can I find the percent of carbon 12s that I have? Okay, I can't hear you because these guys are having their own conversation. Shh, you need to be quiet. Okay, so we're going to take what number? 7 divided by 12. Good. So if we're going to write a formula for that, formula is going to look like this. The part that we're looking for, and the part is carbon 12. So I'm just going to designate it down here. That P stands for part, that is carbon 12, over the whole thing times 100. So the part that is carbon 12 is going to be 7, which is what Isaiah said, over the whole thing, which is 12, times 100. So can somebody give me the percent that is carbon 12? What's 7 divided by 12 times 100? 58.3? Okay, 58.3%. I like it. And what's the percent that is going to be carbon 14? Say it again. 41.6.
Yeah. Or no, 0.7.
I was going to say, that doesn't make sense. All right, that makes more sense. 8, 9, 10. Yeah. Now, these two right here should add up to 100, right?
Yes.
Okay, because it's 100% of the whole thing. Okay, we can now use these percentages to calculate the average of this sample, the average mass of this sample. Okay, we're going to do it two ways. I'm going to show you the old-fashioned way, the way that you would do it in math, and then I'm going to show you the way we would do it in science, because obviously we can't specifically count them just like I have them on the board here. So if I take these carbon 12s, 1, 2, 3, 4, 5, 6, 7, I have 7 things that weigh 12. 12 plus 12 plus 12 plus 12 plus 12 plus 12. Is that 7? Nope. Plus 12 more. And I had 5 that weighed 14, plus 14, plus 14, plus 14, plus 14, plus 14. Can I squeeze it in there? 1, 2, 3, 4, 5. And I divided that, add them all together. Oh, you can't see. Add them all together and divided it by, how many did I have here? 12. Let's do it. So 12. Yeah? What does this add up to? I got 154. And then divide it by 12 things, right? And then, what'd you get? 12.83? Okay. So we can all agree that this is the average. Right? Okay. Now let's do it the science way. Okay? The way that you have to do it, because you can't physically count atoms. Right? What we'll do is, I need the percentages. Let me just take a copy of this. Boop, 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 boop. Copy. And let's do paste. Okay. So here we have 58.3% of carbon 12 and so 41.7% of carbon 14. So this is how you do it. You're going to take the sum. You've seen this symbol before? You can't see it. Seen that symbol before? Okay. Of the percent times the mass. Okay? So what that means is I'm going to take that percent, 58.3, I'm making this harder than it needs to be, 58.3, and I'm going to multiply by its mass. What was the mass of this one? 12. Plus, because that's what that little summation sign means, 41.7%, this is a percent, times 14, and when I do that, I should get the same answer as when I did this. I should get 12.83. Now remember, this is a percent, 58.3. So how do I get it to put it in my calculator? I can make it into a decimal. So 58.3 becomes 0.583 times 12 plus 4.417 times 14. Tell me what you get. 12.83? You should have. You should have gotten the same exact thing. Okay. So this is how we are going to do it, because what they're going to do is they're going to say, you have a sample You with me? Can I turn the page? Okay. Let's say we have a sample that is 95% magnesium 24 and 5% magnesium 25. Okay, 2 questions I'm going to ask you here. The first question I'm going to ask you, before you do any math, what is my average going to come out closer to? 24 or 25? 24. Because 95% of the time, I had a mass of 24. And only 5% of the time, I had a mass of 25. So my average better come about closer to 24 than 25. That's the way we can check ourselves. You also have to say to yourself, my average cannot be lower than 24, and it cannot be higher than 25. All right, let's do the math. 95% times 24 plus 5% of 25. To put your percentages into your calculator, you need to change them to decimals. So 0.95 times 24 plus, how do you change 5% to a decimal? 0.05. You are very smart. And now we can do some math. I have no idea what the answer is because I made these numbers up. So let's do it together. 0.95 times 24 plus 0.05 times 25. Tell me if I got this the same as you. Guys, I do make mistakes. You got the same thing? Okay. Here's the kicker with these questions. First off, there is always one of these on the Regents. Always. 100% of the time, this question shows up on the New York State Regents. The kicker is, they don't always ask you for the answer. They ask you for the numerical setup, which is this. They will ask you to write out the work. So for those of you who were doing it in your heads, or those of you who were like, oh, I can do this, that's not what you're going to be asked. You're going to be asked this. Okay? Tomorrow, because I know that the bell is getting close to being rung, we're going to practice these questions. I'm going to have you write them out. And I'm going to show you one other way that they may present it to you so that you know how to answer these questions. Okay? All right. Let's stop this.